Okay, so you may start now. Thank you.
Okay, I'm live. Okay, now. Okay, so hello everyone. Today we're going to be talking about containerizing Docker applications on using Kubernetes on AKS. Well, my name is Lucas. I'm a cloud advocate at Microsoft. I'm currently based in Brazil, so I'm talking to you from São Paulo right now. All my social networks and everything you need to connect to me, ask me questions, anything, you can just go onto my website. It's down in the page, and you can just send me a message, ping me. I will be ready to answer whatever question you have about this topic or other topics, everything you want to know. And another thing, these slides will be on my Twitter too, if you want to go there and follow and see the slides. Also, there will be a link to the slides at the end of the presentation, so you can follow along. But well, anything you can ask me. Okay, so to start talking about AKS and containerizing applications using Docker, first we need to know what is Kubernetes. So I don't know how many of you who's watching is actually fond of Kubernetes or already used Kubernetes once. So I'm going to start from the scratch, assuming that you don't know anything about Kubernetes and whatever. So basically, Kubernetes is a container orchestration tool. Was created by Google in 2000. It was built from other two projects. The first project is called, I think, was called Omega, and the second was called Borg, and then Kubernetes. It uses like the Linux containers environment to orchestrate the applications inside it and make it very easy and flexible to scale and to balance the load. So you can have like a very available and a very resilient application on your network and on your company and so on. It was only open sourced in the first version in 2015. So since then, it's now maintained by CNCF, which is the Cloud Native Computing Foundation. It's a branch of the Linux Foundation, which has like several other awesome projects like Helm. And came to solve like distributed software issues. So basically, what issues are we talking about? Okay, so the the primary issue with the distributed software is communication mass. So once you have like a lot of softwares communicating within a same system and with each other, it's very complicated to keep track of what's happening. And basically, we have something that we call the esoteric error messages, because sometimes you have an API gateway or something like this that access another system. This system access another system that access another system that access another system, and this other system may or may not access an external provider, maybe an email provider, I don't know. But in the middle of this chain, something gives you an error, okay? And you don't know which one was the service that gives you the error, because only the API gateway will answer the error to the user. So it will look like an API error, but it isn't. It's just like a software in between that has this problem. So basically, it allows you to, it doesn't solve the issue for you, but it allows you to log better error messages, as I'm going to show later on. But one of the greatest features of Kubernetes is the ability to auto scale in a single click, as I'm going to show you in the demo. It's very simple, it's very easy, and it's straightforward and native. Scaling applications using your common method of VMs and so on is very, very complicated, because you have to set up service discovery and so other stuff like load balancing and other stuff. Deep tracing is something that's deeply related with esoteric error messages, because you need to know what kind of messages are the services sending to each other, and which order, and how long it's taking them from to travel from service to service. So this is what we call deep tracing. We have logs from each service, and you know all the chain of logging and all the chain of messages that were sent from one single request. Network routing is something that's actually very complicated to do manually, because you have to, network discovery and so on. And Kubernetes abstracts all of this for you, so it's very simple for you to do it. Distributed management, it's something that's related to people. It's very complicated to manage a huge inventory of databases or data centers or even VMs machines, because you need to have like those tools like Ansible, Chef, Puppet, and other tools to manage several services and several servers on like a different way. And Kubernetes has one single point for managing all clusters, so it's very simple for those who are managing. And this is what a simple distributed system looks like. This is a, let me get my pointer here. This is a graph that I took from the HKOSCon. I don't know if it was 2018 or 2019, but this is a simple architecture of a simple microservice based application. So we have like the clients here. So this is the user. This is the computers, the mobile phones. You have an API gateway, and this API gateway all connects to REST APIs along the whole. This is a service mesh on the whole mesh, and this services can connect to external adapters like this on payments, so using Stripe, Twilio, or SendGrid for communication, for instance. So this gets very complicated, and well, basically what the problem that Kubernetes came to solve can be explained in a timeline on a container evolution. So first we had libraries that were shared with applications inside guest OSs, inside common VMs. This is the architecture of a common VM. Okay, so you had a host OS over here, and you have to install like several guest OSs fully to support your application. So if you needed to install like Windows, you need to install the whole Windows operating system. And if you need to install like Linux, you need to install the whole Linux operating system, and you need to install this on copy. So you had like several libraries on the same machine, because you had like, I don't know, 5 Windows VMs, and you have like 5 copies of the same libraries and 5 copies of the same kernel. So this was this was not efficient space wise and time wise, because VMs may be several gigabytes in space and may take like up to 10 minutes to start up. So this was not very cool. Then we took containers. Containers are actually a very old approach. They come from Linux containers back in the 70s or 80s. So they are not new, but Docker may be like democratized this whole container stuff, because they created a simple interface to mess up with containers. So it's very easy to use containers nowadays because of Docker. But there are other providers like Rocket, for instance. But containers, they remove this problem of the shared library space and time stuff. Okay, because all the containers share the same libs. So you only have like one host OS, and everything, in the both cases, everything is hypervised by a hypervisor. So you had an VM hypervisor here, and you have the Docker engine that acts like a hypervisor. But you don't need to install the whole operating system. You just need to install the different libraries that comes with your application. So these libraries are shared amongst the application, and they share the host OS's libraries too. So basically, this was the evolution, because containers may wait like 500 megabytes instead of gigabytes, and spin up in half seconds and instead of minutes. Okay, and Kubernetes come like a wrap around everything. So Kubernetes can orchestrate all these containers like a machine that's made to keep states. Okay, so we're gonna see this in action in the future. So this is something small glimpse of what you can do with Kubernetes, not Kubernetes native, but there are several plugins for Kubernetes like Istio and Kiali. Both, one is made by Google, Istio is made by Google, and Kiali is made by Red Hat, but they're open source, and you can do it. You can create this service mesh interface, and you create this whole map of stuff just by getting these plugins to work. And they use like other open source projects like Envoy, which is the proxy from Lyft, and so on. So Kubernetes is heavily open sourced. And how it works. Okay, so Kubernetes is based on clusters, which means that you have a master node, which is the one that controls, actually not controlling, but that creates and receives information from the worker nodes, which we call kubelets too. And inside the worker nodes, we have node processes that we're going to talk in a bit. But zooming in into the master, you can have like several services, core services into the master node. There are several architectures for Kubernetes, but I'm not going into these details. You can have multiple masters, you can have one single master in several nodes, but this is all going to be explained like in Microsoft Learn, where you can find several awesome Kubernetes courses. And you can find this on any website because it's very easy to understand. But what I'm going to explain here is how the Kubernetes master works with the cluster itself. So inside master, you have the scheduler service that actually receives all your requisitions for creating new workloads and puts these workloads into available nodes. So it knows which node is available and which node isn't. And you give these calls to the Kubernetes via an API service. This API is a simple REST API powered by JWT, and you can just send like simple and easy requisitions to create new workloads and create new stuff. Okay, so basically, this API is within the master node, and it gets your requisition, transforms into scheduling, and this scheduling goes to scheduler service. Okay, the node controller is responsible to control the nodes, of course, but how does this happen? Okay, the node controller receives all the information from the nodes and tells if a node is okay, if it's up, it's running, it's in desired state, it's not, it has enough CPU, is enough memory, has enough resources to support the workloads that's currently being scheduled on. Okay, and to keep all this state and keep all these things running together, there is this state storage. The state storage is a key value database provided by etcd. Etcd is another open source project of a distributed database made by CoreOS. It's very great, it's awesome. And that's why they use it, because it's distributed, so you can create like a cluster of state storages, so you don't lose your state storages. Okay, this is another architecture. You separate the etcd from the master, and you can have like multiple etcds on the same place, and you can sync nodes and sync clusters across time zones and across things. That's very cool. And zooming in into the worker node, you can have like your application running within the node. Remember that all these nodes I'm telling you here, everything here is a machine, it's a virtual machine. So it's a physical server, okay? So this is a machine, and this machine has your app inside it. But that's the amount of containers you can run within a machine is limited, okay? So these containers require CPU, they require memory. So you have a limited amount of resources. Okay, so Kubernetes can manage all this to you, and that's why Kubernetes is built upon a cluster-based architecture. Okay, because it can make a single machine work, multiple machines work like a single one, a huge single one. Okay, and the kubelet is the service responsible to take metrics out of this node and sending them up to the master. So it takes like the CPU metrics and so on, and send them up to the master, and receives the requisitions to create other apps here, and the proxy that cares about the networking. And as I said before, Kubernetes has only one single point of control, which is kubectl. Kubectl is a CLI to control the Kubernetes in the single point, and it's the human interface to the Kubernetes API. Okay, so it's the only way you can interact with Kubernetes and create new stuff over there. It's based on config files, so basically you can transpose different hosts just by copying your state file, your config file. You can host it online or something. You can cryptograph it and host it online, and you can access it on any machine. It's the full CLI to all Kubernetes-based apps. So basically, no one uses other stuff. So this is the only tool. And this is the basic architecture of how a Kubernetes control plane look like. There's the users, the kubectl to interact with the servers, and you have the API servers reading and writing to the state storage over here. This is another architecture, and creating the resources over here on the machine. Okay. Another thing that makes Kubernetes great. This is from a Helm. This is from a Helm file, but another thing that makes Kubernetes great is the existence of YAML manifests. Basically, everything you need to do, Kubernetes is declarative, okay? You don't need to tell it what to do. You just need to describe what you want it to be doing. So basically, what I'm telling him here is that I want a deployment, and it's going to, do whatever it takes and create a deployment for me. Basically, whatever you need to make a containerized application run on Kubernetes is a single YAML file with a image, like with this section over here, template. So just saying how you want your containers to run. You're saying the name of the container, the image of this container, and the image pool policy, the port that's going to be exposing, the resources it uses, the resources it's going to be requesting, and the volumes and so on. You describe everything in YAML files, okay? So it makes very easy to version your infrastructure in general, and makes very easy to share with other people how these things are going to do. Kubernetes doesn't have templating like this file does. This is a Helm file. This is for another day, but it's very cool nevertheless. But the problem is that when you start to install Kubernetes from scratch, things get very messy, okay? And you don't know how things just work because they just work. You don't know what you did. The control plane is very complicated. That's why there are managed services, okay? The two difficulties we have is like network discovery, like I said, and clusterization. Clusterization is not an easy process, okay? Proxies are not an easy process to do. DNS resolutions, load balancing, and volumes are also not easy to do. That's why we have managed services. AKS is one of them. There is a lot of other services, but we're going to be talking about AKS specifically, and why we should move to the cloud in general, okay? Because it's faster, it's more efficient, because it's faster. We don't have to be creating everything from scratch over and over again every time you need to, get another node up and running. It has less manual work. Just create some things, and you can automate all the process because of the CLIs and integrations among Azure and all the other stuff. Because Azure runs on REST interfaces as well. It has maintenance. You don't need to be giving maintenance to physical servers because it's a cloud. Okay. It has more equipment variety because let's think for a second. If you're doing, I don't know, machine learning, and you need to train a model, and this model needs, super powerful GPUs that you don't have. Probably Azure has. So this has more equipment variety, and you can use more variety inside one single cluster. You can have node pools from several types of machines, and you can choose which machine this is going to be running on. But why AKS specifically? Why not all the others? Okay, it's easy and simple. It's honestly one of the easiest and one of the simplest ones I have ever used, and I've used all of them. There is no paying for the master node. This is differently for each managed services. Each managed service has this the pricing options. AKS only charges you for the resources it creates to run your Kubernetes cluster, so all the VMs and the DNSs and ingresses and egresses from network, which are common because of these virtual machines. But this is for all of the services, and all services have different pricing options. It has a routing out of the box, as I'm going to show you on the demo. It has a cluster auto scale. I'm not going to show you this on the demo, but it has a very simple cluster auto scale, and you can set it up. It's very simple to do. It has native monitoring. You have everything that's happening inside any VMs and inside the cluster. You can monitor, and you can have logging. And it has something that's called virtual nodes. So virtual nodes is the same. It's the most amazing stuff that has happened over the years, because virtual nodes take the power of the Azure container instances, which are on-demand container running machines. So you can run your stuff inside containers, and they're just gonna be running over there. You don't need no infrastructure down below, underlying infrastructure actually. So basically, what you have is a series of containers that's going to be running within Kubernetes. To easily exemplify this, let's imagine you have a store, or you have a store that's receiving a lot of messagings from a message queue. Okay, so you have a Kubernetes node, and every time a message arrives to your message queue, your Kubernetes create another pod, another container to process this message. This processing takes 2 seconds, but it's another container that's going to be up and running to process another message. Okay, but you are like on Black Friday. And Black Friday actually does a lot of stuff, does a lot of damage to the servers, and now you are full. Okay, remember that you have a physical amount of stuff that you can put inside a node because it's a VM, and this cluster is going to be auto-scaling. So if you're using normal auto-scaling, you are gonna be having some serious troubles because the newest messages arriving here wouldn't be processed because there wouldn't be space to spin up a new container. So this process takes a while. All the scaling takes a while because it needs to create a new VM. So you can just put on this to virtual nodes, and virtual nodes will run this smoothly, whatever the cost and everything. So they're gonna run these containers endlessly. You don't need to have this or this. You can also use the virtual nodes as a pool where you put newest things that's going to be up and then pass them on to the OD scaling. This is a bit complex to do, but it's very easy to make too. So in order to show you this demo, I've recorded it because the whole process takes a while. I hope you can see it. I'm gonna be just passing them on. As you can see, I need to register some things before using virtual nodes on my machine, on my Azure subscription, because this is a preview feature right now. So it's going to register all the stuff. This is on the tutorial as well. I have the provider registered over here. Then I'm going to create a new Kubernetes cluster over here. I'm just going to call it virtual nodes demo and virtual nodes, select a region. I'm going to select a new VM size. This is a small machine, one single node, just a demo. And this is where I want to take you. It has a virtual nodes radio button here that's going to be enabled over here. And then that's it. Virtual nodes is already enabled. There's nothing else you need to do, okay? Authentication, and it has this thing called HTTP application routing over here. This is the routing out of the box. You activate it, and you will have DNS resolution out of the box in simple and fast way. Okay, so you can just create the Kubernetes cluster. And this is actually a demo where I show you three things. I'm going to show you the auto scaling. I'm going to show you the HTTP application routing at work. And I'm going to show you the virtual nodes demonstration. Okay, so it's going to be creating the cluster for a while. I spin that up because it takes a few minutes. Fast forward it. So it's easy. I can just put to connect the AKS to my kubectl. I can just put AKS get credentials, and it's already linked to my Kubernetes here. As you can see, it's at virtual nodes demo. And then I can get my nodes, and you'll see that's a virtual node ACI over there. Okay, so the application we're gonna be deploying is the Party Clippy. It's a very, very simple application that actually just outputs a message with the word character, that Clippy character from Microsoft Office, saying that it looks like that you're going to be building a microservice, right? So basically, this is the declaration file that it's needed. Just this tiny bit over here is just a declaration file that needs to be spinning up this container. So I'm going to deploy something called deployment. I'm not going to be into this stuff because I have no time to do it. But this deployment is going to be called Party Clippy. And this deployment is going to have several containers with labels called Party Clippy, with a label app called Party Clippy, and with a value Party Clippy. And the containers will be based on the image of this guy over here. The name of the container will be Party Clippy, and it will request 100 millicores of CPU and 128 megabytes of RAM. And it's limited to be running at 250 millicores and at tops 256 megabytes of RAM. It has a TTI because it's a command line. So it's going to spin up a shell, and it's going to run Party Clippy, and it's going to expose everything on 8080. And everything here is network related. So this is the service that groups this thing into one single IP address and does the port forwarding to the port 80, from the port 80 to the port 8080 inside this container over here. Okay, and this is ingress, as you can see over there. Here, I'm using the HTTP application routing. So basically what it's saying is that once I spin up this ingress over here at this, let me zoom in, at this host, it's going to create a DNS record in my DNS zone inside Azure, and it's going to expose this thing to the web, okay, without me doing absolutely anything. Okay, so this is everything I need to do to expose things to the web. And basically what it does is that it tells that everything that comes with this host goes to this port on this service. And this port on this service, that's called Party Clippy, goes to the port 8080 on the app Party Clippy, which is here. So we are just porting forwarding stuff. Okay, so I just do like a kubectl apply and pass on the file, and everything is created. And I can see that everything has been created. It's okay. And now I got to my DNS zone, and my DNS zone shows that I have created two different DNS records. Okay, so basically I'm going to access that thing, and you will see that this is a microservice running on the cloud. It's very easy and very simple. And this is the HTTP application routing on. Okay, this is the HTTP application routing add-on doing its work. And as you can see, I have one single pod. Pods is a container or one more containers, but I'm not going into the statics and the technical stuff. But I want to scale that up to 30. Okay, so as you'll see, I have 6 running and I need 30. But there's only 6, and why are not the other ones running? So I'm just describing the pod, and as you will see, the nodes don't have available CPU to run this because it's a virtual machine. So as you'll see, the applications can use a maximum of 250 millicores. So it has only an amount of millicore that's going to stack up until it's filled up the whole CPU capacity. Okay, so this is the scaling I just showed you. I scaled that up from one single application to 30 applications if it ran more, but only 6 of them got up because it was the only resource they had available. If I had another node, I only have one node. If I had another node, these applications would create another node. If I always scale the cluster, this cluster would create another node and run the remaining application on this one. And if it's still not enough, it would create another node and do the same thing. Okay, so it's all automatic. So now I'm just going to delete everything because I want to show you the virtual node stuff. So the virtual node stuff is exactly the same stuff, but in the end, there is a node selector stuff. And you will see that I'm requesting only 100 millicores and 100 megabytes of each because virtual nodes don't support yet a service resource requisition, okay? And this is what is making it run inside the virtual nodes. The only thing I need is to tell that, the only thing I need is to tell this application that it needs to select a node. The nodes have labels too, and it needs to select a node where the labels of this node is kubernetes.io/role is agent, and beta.kubernetes.io/os is Linux, and it has a label type with a value virtual kubelet, okay? And this is it. That's nothing more that I need to do. Okay, I didn't even need the service here. The thing I want for you to notice is that I'm not going to be accessing this application right now because virtual nodes interacting with DNS services and ingresses need to have additional network configuration, which I didn't do. So basically, I'm not going to access this. I want to show you something. I have a node, I have a pod that's being created. This pod is ready and it's running inside the virtual node, as you can see here, successfully assigned to PartyClip vnode on virtual node ACI Linux. So it's a virtual node. And now I'm going to scale that up to 30 again. You remember that only 6 of my 30 applications actually ran. So now we will see that all the applications is going to run because virtual nodes have no limit of applications. You can spin up like to 300. I did this like last week. It's very cool. So you'll see that all the nodes are creating. And if I keep watching this, you will see that the nodes are getting bigger and bigger because virtual nodes make this possible, okay? So that's the reason why virtual nodes are better suited for applications that actually use small time. So you're just processing a single message or something very fast. and not long running applications, because on virtual nodes, you only pay for the second you're using. So if you use the node for 2 seconds, you're going to pay for 2 seconds of computing power instead of paying for endless idle computation. I don't know, like if the same example of the store closes at 6 p.m. and at 6 p.m. there's no other purchases, you don't need to be running anything after that. So you won't be spending on idle computation no more. Okay, so this is something like a serverless function inside Kubernetes. Very, very cool. Uh, it's not serverless, okay. And there's two known issues, okay. So you can't actually tell the ACIs to that you're gonna need a specific resource amount or request a specific resource amount. It actually doesn't make any sense because it runs on nearly limitless capacity. And networking, it has a additional networking configuration to make it available for the other cluster workloads. Okay, so if you want to expose your virtual nodes in the web, you need additional networking configuration. I'm going to be a few seconds on this slide so I can talk to you. These are all the links that talk about virtual nodes, that teach you to do virtual noding and teach you how to scale the nodes and teach you everything. This one is the slides, and this one is an awesome AKS workshop on Microsoft Learn. New content on AKS is being produced by my team and by me and by others on Microsoft Learn as we speak. So in the future, in a few months, we're going to be having like a lot more content on containers and a lot more content on AKS, and expect more news on Microsoft Learn. You just go on learn.microsoft.com, and it's very, very cool. Okay, so guys, this is it. I hope you enjoyed. This was very fun to. This was a very fun presentation to do, and these are my social networks. If you ever need to talk about me about anything, okay. Thanks so much.